Good morning. Now we're going to see about the topic of microwave and optical communication engineering subject. The topic is microwave active devices. In that, we are going to see about E-plane T. What is an E-plane T? The E-plane T is nothing about the T junctions. The T junction is an intersection of three waveguides in the form of English alphabet, the T. There are several type of T junctions. The T junctions in microwave circuit is a waveguide or coaxial line with three independent ports. Is commonly referred to as a T junctions. Just see about the picture here. There is a two things has been diagrammatic representation has been photo image has been presented here. That is first one is a E plane T and next is a H plane T. The diagrammatic representation of both. See, they are used to connect branch or section of waveguide in series or parallel or shunt. That is series or shunt with the main waveguide transmission line for providing means of splitting and also combining power in a waveguide system. There are two basic types of E-plane T. As previously mentioned diagram, we see about E-plane T that is series, H-plane T that is shunt that is parallel. Now let me see about the E-plane T. An E-plane T is a waveguide T in which the axis of the side arm is parallel to the E field of the main guide. Port 1 and 2 are co-linear arms and port 3 is the E arm that is side arm. That is left and right portions of previous see the left and right portions of E plane T. First is a E plane T and second is a H plane T. Left side um, left and right portions of E plane T and above the vertical direction of above viewing is a E plane section, that is E arm. A rectangular shot is a cut. A rectangular shot is a cut along the border dimension of a long waveguide and is a side arm is attached. That is, a rectangular waveguide is a totally a long length in that we are merging or combining a E waveguide, that is E plane T or H plane T. In this we are connecting a E plane T for the purposes. See, this is a E plane T as diagrammatic representation. In this we can see about the E plane T, the port 1 and port 2 are mentioned as previous diagram and here, and port 3 is a E arm. How the signal has been passed into it and how the main signal is been cut out. Just see about the diagrammatic representation. See, in this input through main arm, that is input is passed through port 1, then the output has been port 3 and port 2 has been mentioned, whereas from the side arm the output section has also mentioned, that is port 3 as input and port 1 2 are output sections. This you see how the input has been passing and the output sections will be mainly it will be out of phase to each others. Example we can see from the side arm input. Output port 1 is one phase and output 2 is other phase, that is out of phase to each other. Next see about the E-plane T series T, that is in this we can see when the wave are fed into the side arm port 3, the wave appearing at port 1 and 2 of the Coulombic arm will be opposite phase in the same magnitude, that is S13 is equal to S minus S23, that is out of phase to each other. In general, the power out of port 3 is proportional to the difference between the instantaneous power entering into the port 1 and port 2. When the port 3 is inserted and input, the output will be from the port 1 and port 2 is difference of two things. Difference arm, that is the difference between the two arms, that is the difference of two arms we are mentioned here. Let us see about the S scattering, that is S matrix. S matrix is nothing but scattering matrix. We can measure the power ranges will be by the scattering matrix only. Normally, in rectangular waveguides or microwave frequencies, we can measure the power measurements by the scattering matrix only, not by the Ohm's law or Kirchhoff's law like this, because the wires are connected for normal wire current sections, whereas for microwave frequencies we can measure only by the scattering matrix, and T matrix also available, but now we are going to see about the scattering matrix. Normally 3 cross 3 matrix has been represented in above section, and actually in the previously we said S23 is equal to minus S13 or S13 is equal to minus S23, as previously mentioned, also mentioned here. The scattering coefficient due to difference arm also mentioned. S23 is equal to minus S13, that is out of phase, also mentioned. And if it is perfectly matched, if port 3 is perfectly matched to the junction, then S33 is equal to 0. When the port 3 is perfectly matched, the input is given to port 3. And symmetric matrix supposed as Sig is equal to Sgi. So S12 is equal to S21, like that. S23 is equal to 32, S13 is equal to 31, like that we can mention it. So in this we are getting an sections from the representation of equation into its application. By substituting the equations, we get the final equations. From the last and final equations, we are getting an scattering matrix 1 by 2 represented 1 by root 2, all has been inserted into the scattering matrix. So this the equation scattering matrix for E plane T. Thank you.